Everyone, this is so awesome. I'm with Earl, and I'm at a Hemp Campus. Is that right?
Hemp Campus.
Hemp Campus. Okay, tell me what this is.
For a better term, this is the Hemp Campus, but this is where we will bring in the raw hemp crop, a bale, round bale. It gets brought into a tub grinder, which isn't quite here yet. It will be next week. And that will grind up the bale and open it up for us. And it will send it through this conveyor.
All right.
And from the other side of the door here.
What do we got? I've never seen this before, Earl.
From there, it will take it through this conveyor into the hammer mill. This is the hammer mill. It basically is a bunch of small hammers in there that will chop up the herd and the whole stalk of the plant. And we're trying to separate the two parts of the stalk, which is the woody inner core called the herd, and the outer fibers that surround, that are glued to that herd. They have a lot of natural glues, lignins that are holding that together, and it's a real kind of a difficult process called decortication. So we're trying to separate those two so we can get the herd that we want, clean construction grade herd. So from here we chop it up, and then that material will be sent into the shaker table, which is a vibration table. This will get really loud and vibrate, and it'll shake the heavier herd pieces to the bottom, where they'll be collected and sent to the final herd location. The fiber and the rest of that herd that's attached to it will then go up this conveyor into our air classifier, which is the last step in the process, where the material will be blown up into the air. The heavier herd pieces fall to the bottom and are collected there. The lighter fiber pieces are caught at the top and then sent back into the final collection area for the fiber. So here's the end product. This is the herd. They just look like...
That's the end. That's what you want.
They just look like, yeah, little wood chips. These are a real ideal size. We don't want them too long or too short, but those are real good for construction. Here's what the fiber kind of looks like. You still see there's herd in there, but this is about as close as we can with this. Sorry. We can do further cleaning depending on what we need, who's the end buyer for that fiber. And from there, this isn't the final location for this machine. We just got this in. This is a mud hog, just like a cement mixer, where we will combine the herd that we got from the processing, combine that with a lime-based binder and water. It's 4 parts hemp, 1 part binder, 1 part water. By volume, by weight, that equals about the same weight between herd and binder. So it's basically the same weight, but because hemp is so light and compared to the binder, that it's 3 parts to 1 or 4 parts to 1. So then we mix that up just for like a minute. It comes out, and we can put it into buckets and pour it into formwork for hempcrete construction. Not really the way we want to go forward, but it is the way that you kind of learn how to do it. That's what this facility is for. The other part of the facility will be where we are producing wall panels and blocks that we can pre-cure here. Pre-cure means just drying it out, drying the water out. Then we can just bring those to wherever the construction site is, whether it's here or we ship them to other contractors who will use hemp lime construction materials eventually. But this will be the production facility for those wall panels and blocks.
What is hempcrete?
Hempcrete is it's a biomaterial, so it's like our own bodies. It's a plant, and it was once a living thing, so it can absorb and adsorb moisture throughout its fabric, which is something the current construction industry cannot do. Our current conventional methods are an attempt to keep moisture out of the home no matter what, vapor barriers and things like that, but they never really do. There's always condensation happening between the walls. So what we want to do here is have a material that is accepting of moisture and can use that moisture to regulate the indoor humidity. So that's what hemp will do. Naturally, it will keep a perfect humidity level inside the home or inside the building. And if it's too hot, too sticky, too humid inside the house, it can take some of that moisture and take it through the fabric of the walls to the outside and vice versa. So it will really help with temperature control. We hopefully will find out more about how well it can do, but the industry has touted
It's a working facility here.
50 to 75% reduction in heating and cooling costs. So
Wait, what was that, 50 to 70%?
75% depending on climate. So Minnesota's an extreme climate. We hope to see that higher end of 75%. California, you probably don't need that very much, but it's a material, it's a strong material. Over time it will harden and petrify. It's, if you take out the climate issues or the climate benefits from hemp, just as a practical sense, it can save you money through heating and cooling. And
maybe we should take this outside. Better out here.
so over the time, as a homeowner myself, 30 years, we've dealt with mold issues. We've dealt with pest issues, and that's where the lime in the equation for hempcrete. Lime, nothing can eat lime. It's very non-toxic, so no mold can't grow on it, and it's virtually fireproof. So we've had our own torch test where we've put a torch on the wall for 12 minutes, and it will make smoke, but it will never combust. So it's really great for fire issues, but that smoke that it does produce isn't toxic like the materials that will burn in a conventional home. So we're creating a healthier home that will, over time, that lime will pull carbon out of the atmosphere and begin to harden and petrify. So you can measure hempcrete homes not in decades but centuries. There's not a lot of examples in the world. It's only really been used in Europe since the late 80s to early 90s. And but there's a bridge in France that was 1,600 years old where hempcrete was discovered. They've wanted to know why this bridge, which is still in use, and what it was made of, and they tested it. It's hemp and lime, so that's kind of where it all began. But we hope to find out if all these things are true, but the main reason, I think, is that we want to control our housing development, have a little more control over it, and give our members somewhere that's better. It's going to last longer, it's going to be healthier for them, and save them money. And there's benefits to hemp when we grow it. The soil remediation that hemp gives to the field, that most of our cash crops like corn and soybeans will take away from the soil and pull nutrients out of it. Hemp will restore some of those nutrients, so the crop you plant after hemp will have a higher yield than if you planted without hemp previous. So the carbon that hemp pulls out of the atmosphere is like any other plant, any agricultural plant, and more than trees. So really, on the embodied carbon that it pulls out is reduced dramatically. The carbon that's pulled out during the life of the home while the lime hardens is tremendous amount when you combine the two. And then the operational carbon going forward, when you don't have to use as much heating and cooling, is also a benefit to fighting the climate crisis that we're in.
What's your hope? What's the goal of this for next 5, 10, 15, 20 years?
Right, it's more than just building homes in the community. It's a workforce development that we've had people in our community that have been working in the trades, especially the construction trades, for generations, and Lower Sioux just never had their own construction crew company. We want to combine plumbing and electrical and site work and really control the whole process from start to finish of construction. So in the next 5 to 10 years, it's really hard to tell where this goes, but I want to hope to be producing those wall panels and blocks in a modular design and satisfy our needs in the community, but also have a potential commercial product that we could sell to outside communities that want to build with hemp and lime. So it's just in the prototype development stage, but 5 to 10 years, hopefully we're somewhere else and you can come check us out. I have no idea where it'll be though.
Awesome, I love it. I'll be back.
All right.
Thanks, Earl.